So on this lovely day, we are going to basic terms of geometry today. So we're going to look at something called a point, a line, a plane, a ray, etc. Now, using your book and with your partner, we're going to walk through is, so we are going to walk through this. So let's look at the very first point. First one. Now, the reason why I say here definition with quotes around it is because sometimes some terms are undefined, which means we actually kind of just say that's it without really knowing all the definitions. In fact, there are 3 terms that are undefined, so please go ahead and write that down. These 3 right here, a point, line, and plane, they are called undefined terms. Undefined terms. One way is because we can't really express it in geometric words because we don't have geometric words yet. Second, we could also say they're undefined because they don't actually exist. There's no definition to it when you draw. There's nothing there when you draw it. It's there and not there at the same time. Okay, so the first thing, a point. It is a 0-dimensional dot, and it represents a place, a location. That's what it represents, a point. So it is the first geometric term that we are considering. This is how we draw. You put a little dot, and we always use a capital letter. For some of you ladies, you like to use lowercase and uppercase interchangeably. In geometry, we have to be using what we have. So in this case, it will always be a capital letter or uppercase. So make sure to use uppercase when we're talking about a point. And all we have to say is, we just call it A. That's it. You could also call it point A. The abbreviation for point is PT. Either one of these is a good way to name it. Oh, so you're traveling from A to B. We just say A. We don't need to say point. But you could say, I'm traveling from point A to point B. Either one are sufficient ways. But it does have to be capital letters. Some non-examples or bad habits would be another way of describing this. Is if you said this with a lowercase, that would be wrong because it needs uppercase. Also, if I just have an A right here, that's not a point. That's the name of the point. Because it's missing the dot. I know it's a little bit confusing, but capital letter is the name, but when you have the dot, that's the actual point itself. And by the way, it's not there. It's there and not there at the same time. It has no dimension, so it doesn't exist. But we have to put something down so that we know where we're talking about. All right, so like we said, line is undefined because we don't have a geometric term to talk about it. So it is one-dimensional, 1D, and it's infinite points, and this little symbol here means infinite points in 2 directions. In 2 directions. Let's even clear that. In opposite directions. Let's change that. Opposite directions. All right. So a drawing can be like this. Like so. And I do need at least 2 letters in there to give it a name. When we talk about postulates, we'll see why in a little bit. How do I name this one? There are 2 different ways to name it. We can use the points like so. The points like so. This is one way of naming it. Line CD or line DC. However, the other way of naming it is I can use like an italicized or a handwritten letter, like that's a K, and you could call it line K. like that, line M. We use lowercase, and it's usually kind of like cursive or italicized. So a non-example, you have lots of different ones, but this is not a line, at least as it's represented. It is not a line because it's missing the infinite going in that direction. All right. Next. Okay, the next thing is called a plane, and a plane is two-dimensional, and it's a flat surface. A flat surface. And goes on forever in four directions, like north, south, east, and west. One way to draw it, and generally speaking, we almost always draw a plane in this sense, like a parallelogram. There are two different ways to name it. You can just name it with a letter in the corner, and this one here is called plane A. Now, this letter in the corner, in one of the corners, does not mean I'm talking about the point. I'm not talking about this vertex here. I'm saying that this A represents the whole thing. The other way to name it is by naming it according to three different points that are there that are not collinear. They can't be in a straight line. So another way to name this one is plane CDE. And technically, you can write it in any order you want. CDE, DEC. Because I'm not talking about the triangle that's formed. I'm talking about the plane, the surface that contains those 3 points. Here would be a non-example. You could draw the plane, and then when I have on it a line, I would not name it like this CDE. Why not? Because plane CDE here does not describe one specific plane, because it describes an infinite number of planes. It's really hard. All right, most of you probably got this one already. And just to remember, for those of you who speak Spanish, co or con means with, together. So this says 3 different things. Points that are together on a line. Points together on a line. Points on a line. Points on a line. So for example, you just draw a line, and notice technically you don't even need to have the arrows to make it collinear, but in this case, A, B, C are collinear. A, B, C are collinear. And that's just all I would write right here. It's a list, A, comma, B, that's not a B. A, comma, B, comma, C is the list of the points are collinear. So actually, I'm naming it with a sentence. Non-collinear lines would look, or non-collinear points would look something like this. Is I have 2 on the line, A and B, and C is hanging out over here. These would be called non-collinear. Non-collinear. So these 3 points are non-collinear. Continuing on, coplanar, we break it up in the same way. These are points on the same plane. On same plane. The rain in Spain falls mainly in the plain. So, again, we're going to draw a plane, and I need to have points on it. So, 1, 2, 3, and 4. Just to give you a heads up, if I were to draw only 3, that's not a big deal. Space is straightforward. Space is just everything. It's 3 dimensions. It's everything. And when I say everything, I just mean that we can see. So technically, this incorporates the entire universe. Of course, gravity affects your geometry, which affects how things work. But for now, space, and the only way we represent it is just with a cube. And that's an ugly cube. Square there, slant back, something like that. And that's pretty much it. And technically, because space is everything we know, we can't have a counterexample unless you just said a plane or something like that. Or you believe in a multiverse. No clue how you get. All right. Line segment. I didn't mean to do that. Hashtag. Okay. All right. Line segment, shockingly enough, we think of it as a piece of a line. We think of it as a piece of the line. Sorry about that. Piece of the line. And it does have to have two end points. Two end points. So, of course, my diagram, a beginning and an end, FL. And this here, FL, is my line segment, or simply segment is fine to say. So FL, when I name it, looks like this. I can say segment FL or segment LF. Both of those work. I would not put an arrow above it or a line like that. I would not say just FL by itself, okay? Because FL means something else. Just FL with no symbol, that actually means the distance, like how far from F to L. And of course, anytime you put an arrow on it, then this is not a segment. Now let's, all right, Ray, is that guy down the street that's really weird, stares at you in weird ways? No, I'm just kidding. Ray is half of a line kind of thing. It has one endpoint, and then goes on forever. Forever. Anyone know what movie is that from? Forever. Do you know? Sandlot. Bing, 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 bing. All right. Just to give you a heads up, this ray right here has a name. It starts at A, goes through B, and there's my arrow. The arrow always goes in that direction because this is just a name. This arrow does not tell you which way it goes. It doesn't say it goes from left to right. This just says that it is a ray. So, for example, I would not say BA because this one says I start at B, go through A. Start at B, go through A in this direction. And it doesn't. So this would be a non-example in a sense. It's a non-example of that particular ray. Now, ray BA exists. I just didn't draw it. Another thing is A, B. We don't use, I would not use a letter like this because that only talks about for lines. Okay, so ray. And opposite rays are rays with same endpoint in opposite directions. So it might be easy for us to see. So here's my endpoint. A goes in this direction. B goes in this direction. C. And what's true is that CAB are collinear. CAB have to be collinear. A non-example would be this, where it goes off in this direction, but it goes off in this direction. They do have the same endpoint, but the A, B, and C are not collinear. So those would not be opposite rays. Now, by the way, using this diagram here, AB ray and ray BA are not. These are not opposites. We often get in our head that, oh, well, opposite just means, flip things around. No. This one starts at A, goes through B. This one starts at B, goes through A, which now creates an overlap right there. So there's no overlap on rays, opposite rays. Oh, and one other thing to consider is that opposite rays form a line. They form a line.